Welcome to SmokeGuard's AIA Continuing Education series. Today's AIA course is titled Passive Fire and Smoke Protection for Atriums. This course has been approved for one learning unit for health, safety, and welfare with the American Institute of Architects. SmokeGuard is part of the Engineered Building Solutions Group, a segment of CSW Industrials. The EBS group unites Balco, Metacock, SmokeGuard, and Greco. These four leading brands provide innovative, safety-focused solutions for architects, building owners, engineers, and contractors with a shared commitment to life safety by design. SmokeGuard offers flexible, visually appealing fire and smoke protection systems designed to cover everything from small openings to large atrium spaces. SmokeGuard offers a full line of elevator smoke containment systems, including vertical, horizontal, and perimeter fire and smoke curtains, as well as shutter and static curtain solutions. SmokeGuard is a registered provider with the American Institute of Architects CES program. This course is approved and in compliance with AIA. This program is not intended to promote any specific construction material or method of use. At the completion of this video course, you will need to take our 10-question test and get 70% correct to receive your AIA Certificate of Completion. You will receive your certificate via email. If you are an AIA member and you provided your member number, we will report your course completion to AIA for credit. Please allow for up to 10 business days to report credit to AIA. This presentation is copyrighted by SmokeGuard. Any reproduction, distribution, display, or use is prohibited without written permission. In this course, you'll review key code requirements for atrium design and learn how fire and smoke curtains contribute to sustainable building practices. You'll see how these curtains can supplement or replace traditional smoke evacuation systems, offering energy savings and reduced mechanical costs. Additionally, this course will cover how to properly specified curtains can extend evacuation times and enhance occupant safety during a fire. This presentation was pre-recorded by David Bauer. David is the Architectural Director for SmokeGuard. With that, let's turn it over to David.
So, since we are talking about passive systems, and since the focus of this conversation is going to be on fabric passive systems, why are we bothering to talk about this stuff? Why not just use steel? We've been using steel forever. I've been using steel forever. This is one of my projects. I use the steel closure in this opening off of a hospital corridor, which is required to be smoke rated. Nothing wrong with what I used. However, it was about a 22-inch square housing that I put up in the ceiling of this hospital, when today, if I was using fabric, it would be a 6-inch housing. Much easier to do, much lighter, much smaller, much more minimalist, and still satisfies the exact same code requirement. So that's why we're interested in fabric these days. It makes it much, much easier. So as preamble to all of this, we can't really talk about too much of anything in the world of fire and smoke protection without making sure that we've understood the nuances of different types of rated walls as established by the IBC. And we all know firewalls, fire barriers. Those are big fire rated walls that have specialized jobs. And actually, a lot of these are very, very similar in terms of construction. They're very dissimilar in terms of application. So we have fire partitions and smoke barriers, and you see we added that little smoke icon there. Well, that means that those are smoke rated as well. With respect to the actual wall construction, there's really not much difference. And when you get down to smoke partitions, okay, you drop the type X chipboard if you want. Probably won't, just because it's a lot of times more effective just to use the same type drywall in a job. But these are all very similar walls with probable exception of firewalls. However, since the last three of these have smoke rated requirement for them also, the magic comes in the openings. So that's where the key difference is in most of these walls, with the exception of firewalls, probably. So the first two of these that are only fire rated are limited to 25% openings. So if you have an 80-foot wall, your total opening widths can only be 20 feet. So that's a little bit limiting in there. In a firewall, it's not that big a deal. In a fire barrier, it may be that big a deal. And in some cases, particularly in atriums, it's an enormous deal. So it's a big problem if you are forced into using a fire barrier when you might alternately be able to use a fire partition or a smoke barrier instead. So fire partition and smoke barriers, you're not limited to your opening size. So that same 80-foot wall, if it does not have to be a fire barrier, but could instead be a smoke barrier, for example, still fire rated, but your openings are unlimited. So that 80-foot wall, 79 feet, knock yourself out, get as big an opening as you can, or a series of them. There is no limitation in these. And then smoke partitions are only smoke rated, are not fire rated also. There's a little bit of a difference there too. So it's important that we talk about these on the front end so that when we apply them in different scenarios in this presentation, we'll understand what it is, what the base vocabulary is that we're talking about. Other concepts that are important to understand. This is maybe one of the single most important things in the entire code if you live in my fairly limited world, multiple use fire assemblies. If you have a building element upon which there are two separate code requirements that demand some kind of performance characteristic from that building element, multiple use fire assemblies requires that you satisfy the requirements of both of those requirements on that portion of wall or whatever else it might be. So in this case, that little black dashed in box, that purplish section of wall there, it is required to satisfy the requirements of both the red wall below, the 2-hour fire rated wall, and the blue walls above, the non-fire rated smoke rated wall. The end result is that segment of wall right there has to satisfy the requirements of both multiple use fire assemblies. That has to be both smoke rated and 2-hour fire rated. So it has to combine both of those. The language that I've heard far too many times about the more restrictive governs is absolutely demonstrably untrue. Both govern, both apply. The more restrictive governs implies a choice. And there is no choice here. We have to accommodate both of those requirements in that single portion of wall. So let's talk about the atrium definition. Since we're talking about atriums, we should know what one is. In the 2021 code, the IBC decided we're going to change the definition of the atrium. Well, that made things a little bit more interesting. Prior to 2018, you could have a 2-story atrium in a business occupancy, just to pick a certain example. In the 2021 code, the only 2-story atriums that you can have are in I2 and I3 occupancies or in hospitals or in jails, in lay terms. And that's it. Other than that, atriums start at 3 stories. That was not true in 2018. Atriums started at 2 stories. Then there are other requirements that kicked in at 3 stories, most importantly, smoke control. However, an atrium could be defined as a 2-story volume. And that's significantly limited in 2021 and 2024. By the way, all of the code references that you'll see on this page, for example, underlined up above, I'm going to refer to the code section where you can find this. And then that's hyperlinked. It'll take you back to the IBC website for that particular section. So a little shortcut here, and we have a PDF that we can use to support that. And those links are live in that case. So let's look at probably the 2 most important things that we have in the code. The first section we're going to discuss is section 404.6, titled Enclosure of Atriums. The first thing that you read in that is that an atrium, they're not saying 2-story, 6-story, 5-story, 3-story. They're just saying atriums. Atriums are required to be separated from adjacent spaces by 1-hour fire barriers. Well, that's pretty horrific, not because of the fire barrier itself, but because of the opening limitation in the fire barrier. So you can only put a 25% opening in any given wall, or an aggregate of openings in any given wall. So in this ultra generic atrium here, this little demonstration model that we'll be using repeatedly through here, that's what it might look like. You don't have to paint the walls red, that's okay. But for demonstrating for our purposes, the color of any wall will show down that legend in the lower left, and that will be a recurring theme throughout this. So that's what that says. If you stop there and don't read the exceptions, well, you're kind of stuck with this, and that's a pretty unpleasant solution. So, but there is an exception. There are a couple of them, but exception 1 permits substitution of sprinkler protected glass, and they use the words in the code forming a smoke partition. Well, if you recall, about 4 or 5 slides ago, we talked about smoke partitions. Smoke partitions are smoke rated walls. They are not fire rated, they're only smoke rated. So what they're talking about here is you can substitute, in effect, a type of smoke partition for that fire barrier. So the code is telling you can substitute a smoke rated wall for a fire rated wall. And the smoke rated wall has no fire rating, and the fire rated wall had no smoke rating. So you are going in a totally different direction here. And it's exception number 1 right there, and it's been there for generations of the code. So there's nothing new about this. So it does say sprinkler protected glass, and it goes into detail as to what that means, and read those details, but it's not particularly egregious, and you see it a lot. However, it does say forming a smoke partition. When the code uses a term like smoke partition, which is a defined term and it's italicized, then it does mean exactly that. So although doing something other than sprinkler protected glass is no longer a prescriptive solution, it's now an alternative method. It's about the easiest alternative method there is because you can easily build a wall in there complying with the requirements of a smoke partition. But why would you do that? You have sprinkler protected glass, you can see all through the whole thing. Well, because if you use a smoke partition, you can have an opening that's nearly an entire wall. Well, this is a use for fabric curtains. So you can easily accommodate the code requirements for an opening in a smoke partition with a fabric curtain. So in effect, you get a completely open atrium with respect to the requirement for enclosure. So remember, we're still talking about enclosure. We have not yet begun to talk about smoke control. That's a different thing that we're going to talk about. We're going to layer that on top of this, but it's easier to go this way. So, okay, so we have this 4-story atrium hypothetically, and we can protect this with smoke partitions or sprinkler protected glass. And then let's read a little further at the down the page a little bit. Let's get to exception number 5, because this is where the good stuff happens. So in a fairly small atrium, like a 4-story atrium, well, it's actually not that small, you are permitted to omit protection at any 3 floors. And it is any 3. I'm showing the bottom 3, but there's no restriction on that. You can omit protection on any 3 floors. So with respect to enclosure, and again, we're only talking enclosure at this point. All you have to do is protect one of these floors with the equivalent of a smoke partition or prescriptively sprinkler protected glass. We have now completely satisfied the requirement for enclosure of atriums in section 404.6. However, we have not touched smoke control yet. So let's see what we have to do in section 404.5 for smoke control. The first thing it does is it refers you over to section 909. 909 is the meat and potatoes. That's where it tells you all the different things that you have to do to provide a smoke control system, whereas 404.5 just talks about the collective of a smoke control system, what it has to do, when you have to have it, what it has to just generally do. 909 is going to tell you all the specific nuts and bolts that it has to accommodate. So let's go back to our atrium that we were showing a moment ago. Remember, that atrium was 100% code compliant with respect to enclosure. But now we have to layer in the solution for smoke control. So what are our operating parameters? In section 909, it's going to tell you that you have to maintain a smoke layer minimum of 6 feet above any walking surface that's required for egress. And you have to maintain that protection for 20 minutes or 1.5 times the calculated egress time. Well, I can't calculate the egress time. That's fire protection engineer stuff right there. But get a fire protection engineer involved early is better than later, and they can help you through all of these things. And also, a very specific requirement for permitting is a rational analysis. Realistically, that's written, the code doesn't say it has to be written by a fire protection engineer. But fire protection engineers know this stuff, do this stuff all the time, and they are well worth their fee to do this. So if we have to maintain a smoke layer at least 6 feet above any surface required for walking, what are our methods of doing that? Well, the old school way, and for years, really the only way anybody really did this, was with the mechanical smoke evacuation system. Now, remember our enclosure requirements, I'm showing it at the top floor. It doesn't have to be the top floor. It could be the second floor. Well, that changed the dynamic of our mechanical smoke evacuation system, because now we've got to have a much bigger fan getting that smoke out of there before it gets to a point 6 feet above the 4th floor. But we are separating out the 4th floor, so let's make it easier on ourselves for right now. And so we can build a reservoir in there that will hold smoke that will be the equivalent of that time period that we have to maintain. And that's one way to do it. There's nothing wrong with this. But in addition to your mechanical smoke evacuation, you have to have makeup air coming in there somehow. The proportions are approximately the same. And if you pull a volume of smoke out, you have to replace it with approximately the same volume of makeup air. Now, that sounds easy until you get into the mechanics of that. Where's that makeup air coming from? Well, you can have doors on operators. That's one thing. Does that give you enough volume? Probably not. Do you need more than that? Well, it depends on the atrium, and all atriums are different. So you're essentially pairing up that makeup air with the ability to exhaust the same volume of smoke. Well, what have we done to this atrium to make this easier? Well, we've just added curtains, fabric curtains on the 3rd floor. We don't have to do that. We did that. We chose to do that. Well, why in the world would you do that? Because they're not free. They cost you money to put them in there. Well, because they save you more money by diminishing the requirements for placed upon your smoke evacuation system. So essentially, a kind of time-tested rule of thumb is if you spend $1 on curtains, you will probably save about $3 on mechanical system. Remember, it's not only downsizing the smoke evacuation system, but look down at the bottom. It's downsizing your requirement for makeup air. So wherever that makeup air is coming from, you'll need less of it. Well, let's take this another step now and see what else we can do. What if you added that smoke protective curtain on the second floor? Well, you can make that smoke evacuation system even that much less. You'll probably not get it to zero, but that $1.2 million smoke evacuation system may have just turned into a $250,000 smoke evacuation system. And to get you there, you maybe have had to spend some money on curtains. But again, the ratio of savings versus spending money on the curtains versus savings in the mechanical system is approximately 3 to 1. Spend $1 on a curtain, save $3 on mechanical. And that's a pretty valid number to go by. So what have we ended up with at the end of the day? We have a big reservoir in there. We have a minimal need for a smoke evacuation system, and we have kept the smoke layer 6 feet above any surface required for egress, because the separation that we have provided along the edge of that atrium is going to stop all the smoke from getting into that space. Okay, this is a very common solution. Let's take a look at a couple of examples. This is approximately a 7 or 8 year old building at the University of Michigan. And it has 2 atriums in it. The atriums are sort of pie-shaped, and we're looking at the wider end of one of those 2, and they're both twin atriums, so they look the same, approximately. You'll notice that there's a bridge running across there, and that bridge is required for egress. So that's our weak point. We have to keep the smoke 6 feet above that, at least above those walking surfaces, since they are required for egress. So what did the architect do in this case? Well, these are curtains, fabric curtains, deploying down around that egress walkway that goes across that atrium. You notice they provided glass at the upper levels. Could have been fabric curtains, but glass isn't wrong either. So they have effectively provided enclosure on the top, what turns out to be the top 4 floors of this 5-story atrium. That's not required for enclosure. They were only required to provide 2 floors of separation, but they did 4, and they did that so that they could diminish the mechanical requirements. Big money saver for them. Here's another example. This is the University of Mississippi Medical Center in Jackson, Mississippi. And this is a cruciform building laid out like a basilica, and that crossing point where you see those 2 wings up in the distance above the word medicine. That is the point at which there is a 5-story atrium. So what did they do in this case? Well, this is a view of the 5-story atrium. And it's very difficult to see, but you can see a little bit of a curtain deployed at the very top of these. So that curtain will come down and completely separate off the entirety of this atrium with the exception of the first floor. Well, remember, enclosure meant that they only had to enclose 2 of these 5 floors, so that 3 were left open. So they put 2 more floors of curtains into this application. But why did they do that? They did it for exactly the same reason that we've been talking about. They could diminish either the mechanical smoke evacuation system or that paired with the need for makeup air. In this case, they could have put the world's biggest mechanical smoke evacuation system on the roof, but they were limited in the makeup air that they could get into this building. That's because all the makeup air came in through these doors. And if you look at the top of the doors, there's an operator at the top of them. But if you look at each one of these windows, each one of these windows is equipped with an operator as well. So basically this entire wall opens up to provide makeup air. And this is as much as they could possibly get in there. So this limited their smoke evacuation capability, which in turn then said, well, wait a second, we need more than that. So what did they do? They truncated the volume of the atrium by putting in fabric curtains. Okay, this clause was added in the 2021 IBC. It didn't change anything else. It just added another opportunity for you to, in this case, omit smoke control. So you can eliminate smoke control, and the words I'm using are significantly chosen because you can eliminate smoke control by doing this. It's not your means of smoke control, it's elimination of smoke control. The other examples we were looking at accommodated smoke control, gave you a solution for smoke control. This just lets you not do it, but there's a price to be paid. And the requirement is that if all stories above the bottom 2 are protected as you would for a shaft, then you can completely omit smoke control. Okay, well, seeing as how our smoke control system came in at a budget of $1.2 million or something like that, that's probably a pretty good way to go. But let's read on. Let's figure out, well, what's the price of that? Think about what the construction of a shaft is in a 4-story vertical opening. If we had to put a shaft in, and we have to construct this as per the requirements of a shaft, if we have to do that, it's 2-hour separation using a fire barrier. Remember, fire barriers are limited on what the openings can be. So what does this look like in our same little generic atrium? It looks like this. Above the second floor, separated by fire barriers. There is some debate about what the openings can be, but they certainly can't be greater than 25%. And I've heard several people argue that since the requirements for a shaft are that you can't put an opening into a shaft that's not required for the purposes of that shaft, can you really put like arbitrary windows in there, looking in there at all? I think there's an argument to be made either way, but regardless of which side you come down on, we know that we can't exceed 25% of those walls being open. So we've gone through all this trouble to put this nice atrium in there, and look what we end up with. So we don't see this taken as an exception very often. And again, mentioned this a moment ago, it's important to note that this section, this subsection, this exception here was added in 2021 without mitigating any of the other possibilities that you had prior to that. So if we go back to the 2018 code, there were passive solutions all day long in atriums. This didn't change anything with regard to that. All it did was gave you another means by which to omit smoke control. It doesn't change your means of accommodating smoke control with passive systems. About mechanical smoke control, a lot of people have come to the false presumption or conclusion that if smoke control is required, it inherently has to be mechanical based. And that's not true. The code does not favor mechanical versus passive or passive versus active or active versus fabric curtains or anything. You can go passive, you can go active. Either one is in play and the code accommodates both of them. So there is no requirement that a smoke control system be mechanical. So what is a passive smoke control system? Well, let's go back to the same atrium that we've been looking at for a while. This is our requirement for enclosure, right? We have satisfied everything we need to for enclosure. So everything we do from here on out to accommodate smoke control is only to accommodate smoke control. We are stopping smoke. So do we need anything fire rated? We're stopping smoke. We're not stopping fire. We're stopping smoke. That's all we're doing. So what could we do as a passive system here? Well, what would happen if we provided smoke rated separation on the third and the second floors? We now actually have no ability for smoke to atmospherically connect one floor to another. It can't transfer from one floor to another. We do have a 4-story atrium. However, smoke doesn't know that. Smoke thinks we have a 1-story atrium with a really tall space right in the middle. And from a smoke perspective, that's absolutely true. So we see this solution applied as a passive smoke control, satisfying smoke control requirements, not omitting smoke control requirements. If we are omitting smoke control altogether, then we could go with fire barriers, which aren't even smoke rated. But we are accommodating smoke control requirements with a passive system. So there's no ability for smoke to communicate from more than one floor to another. You can make the argument that you can even remove one of these layers. Now you have the equivalent of a 2-story volume, which isn't even an atrium to begin with. Now this for sure is a 4-story atrium. But again, for the purposes of smoke doesn't know that. Let's look at an example of this. This is a 4-story building with a 3-story atrium. And this is the Permitting Development Center in Austin, Texas for the city of Austin. And ironically, this is where the AHJs live. So they're all walking through this atrium all day long. See what it looks like inside. This is the 3-story atrium. And the lowest floor, if you look, anywhere along this lowest floor, it goes back into the adjacent spaces. There's no enclosure provided at all. And if you look now up to the second floor, you'll see that there are spaces up there, but corridors that go down there. There's no separation whatsoever. You get to the top floor, however, and they have provided sprinkler protected glass completely encircling the opening of that atrium. Well, why'd they do that? They provided a means of passive smoke control. They have no mechanical smoke evacuation system in this at all. All they've done is they've denied access of smoke from any more than 2 stories at a time. So there's no atmospheric connection between any 2 stories or any more than 2 stories of this building. They've created a passive smoke control system, and it is an absolutely successful solution. They do have a 3-story atrium, and this is their smoke control solution. They have not avoided it. They have not omitted it. They have accommodated it. They have still provided a rational analysis as required by code, but this is the scheme that they used. So let's look at what they did in this project. Again, we have that little legend down on the lower left side. We are going to use a smoke partition because if we use sprinkler protected glass at the top floor, forming a smoke partition, as it says in the enclosure section, we basically separated it out for the purposes of smoke. So smoke can't get to any more than 2 stories at a time. This is a smoke control solution. It is not omitting a smoke control solution. What else do we have to take into consideration? Okay, well, certain occupancy types require rated corridors. Okay, you know what they are if you work in these is a pretty commonly visited section, or actually we don't even visit anymore because we know it so well. Let's take a look at certain types of occupancies. What if we had an occupancy that had let's say it's a senior living, and you have a corridor going around that atrium. It's a pleasant space. You've got a big open space. You can look down into it. That's nice. You have your enclosure requirement accommodated up there. And we have not yet talked about the smoke control requirement. But what do we know about corridors in I occupancies? We go back to the previous slide. I1 occupancies require a 1 hour fire rated corridor. The fire rated corridor is constructed as a fire partition. Okay, so we have to do this. That corridor has to be protected as you would for a fire partition. So you protect both sides of that corridor, but we're looking at the atrium and the interface of that atrium. That corridor is required to be separated from the atrium, not for atrium requirements, but because it just has to have fire partition walls. That has nothing to do with an atrium. That can be a library or a sitting room or whatever it is, but that separation is required to be provided by fire partitions. So now from the atrium perspective, what else have we then done by providing that fire partition corridor wall? Fire partitions are smoke rated. We provided a passive system for smoke control. What other complications might we have? Well, several occupancy types require smoke compartments. For years, I thought it was only hospitals, and then I read a little more carefully. It's like, oh no, wait a second. We have a lot more that we have to accommodate with smoke compartments, namely jails. What do they all have in common? I2 occupancies, hospitals, jails. People can't necessarily self-evacuate. You don't want people in jails self-evacuating. I think that would be probably a programmatic problem. I1 condition 2. I1 condition 2 is senior living, but it's the higher level of senior living, and it's constructed very much like a hospital. They require smoke compartments for the exact same reason that hospitals do. People in a memory care center, which is listed as a condition 2 of I1, you don't want them self-evacuating. Ambulatory care facilities. What's the trigger point of those? If you have 4 occupants of an ambulatory care facility that are incapable of self-evacuation, then you have to have smoke compartments as well. So that's an important point to make, because the trigger point for that, the code says that if you have a facility capable of having 4 occupants incapable of self-evacuation, now you have ambulatory care. Programmatically, you might say, or your owner might say, well, we're never going to have more than 2. Doesn't matter. If you have a facility that can accommodate 4, you are now an ambulatory care facility, and you have to have smoke compartments. They have to be separated by smoke barriers. They have sides, top, and a bottom, so they can't be common to a floor. You can't have a big, tall 4-story vertical connection and call it a single smoke compartment. That doesn't work. Minimum 2 compartments per floor. Then there's size requirements or maximums. 22,500 square feet is your maximum. The IBC lets you exceed that, but NFPA 101 does not. And well, the 2012 version certainly does not. That is applied if in most hospital applications. Okay, let's go back to our same atrium. If you have the requirement for smoke barriers, because you have smoke compartments and you fail to separate them with smoke barriers, you have a connection of these smoke compartments, and you can't do that. So what do we have to do? What do we have to provide there in that line between the smoke compartments? We have to provide smoke barriers. Smoke barriers can still have unlimited openings. So this is very common in hospitals. What is the requirement for that separation? Well, if you have smoke compartments, that is a fire rated separation. You have 1 hour fire rated walls, but you're permitted to have unlimited openings in those walls. And those openings, however, have to be smoke rated. So you have a smoke rating requirement and a fire rating requirement. The fire rating for the opening is only 20 minutes, even in a 1 hour wall. So this is very doable with fabric curtains as well. But you do have to accommodate the requirement for smoke compartments if that applies in this particular occupancy. What else have we done? If this is an atrium, what have we just accommodated? We have total smoke separation from floor to floor. It is still a 4-story atrium, but again, smoke can't get from floor to floor at all. Let's look at another project. This is one I worked on 20 some years ago. Brand new out of the ground hospital. I was very fortunate to have worked on this with a great company. And I had a 2-story volume right there at the front door. This is not at all uncommon in hospitals. We want to have big, expressive 2-story spaces. But I had a couple things that I had to accommodate, and smoke compartments was one of them. So this was an alternative means solution. The separation between the two is sprinkler protected glass. because as precedent, other sections of the code permit you to do that when your primary separation requirement would otherwise have been fire barriers. So this is an alternative method, but the point is that there was a separation between the second floor and the first floor. Could I have done this a different way? Well, back then, not easily. Today, very easily. Today, you could use something like a fabric perimeter curtain. It has to provide the requirements for the opening in a smoke barrier. But what is that? Smoke barrier is 1 hour, and the fire rated requirement is for the opening is what? 20 minutes and smoke rating. So are there fabric curtains that do that? All day long there are. So they have to accommodate both of those. So this is a diagram of the building section of what we're looking at here. This is that 2-story space in the front. And the requirement is a 1 hour smoke barrier. But again, the opening, 20-minute and smoke rated. By the way, you'll notice the notation for UL 1784. That is the base test required for a smoke rating. If on your door schedule you were to put an S label on there, that is a defined term in the code, and it means that it is tested in accordance with UL 1784 and leaks no greater than the limits placed on it within the building code. So calling that opening in that wall an S label opening is exactly correct to do so. What about horizontal systems? Now, we see these periodically, and what are they actually doing? What if we wanted to put a horizontal system in this atrium? What have we actually accommodated by doing that? Well, let's look at what the horizontal systems are, the ones that are available to us. First of all, you have ASTM E119 or UL 263 systems. These are floor slabs. This is a continuation of the floor. The hospital is going to be rated. It's going to provide that continuity. It actually physically separates the atrium into multiple atriums by definition. So those are two roughly parallel requirements or test standards that you can apply. Well, there are standards for vertical walls, but these are for vertical walls or openings in vertical walls. So UL 10B, the only means of testing with a UL 10B system is for that opening in a vertical wall, not on a floor. So UL 10B provides no language for any opening in the horizontal plane. It's just not defined there. UL 10C for side hinge doors, same thing. NFPA 252, their NFPA cousin, same thing. These are only for openings in vertical planes that we call walls. And there's one standard for openings in the horizontal plane, and that is NFPA 288, floor hatches, roof hatches. If you put one of these in that's listed to NFPA 288, that's great. That is the only thing that's defined for horizontal that's mentioned in the code. However, we have something else that we've been seeing probably the last decade, and that's UL 10D systems. UL 10D is a relatively new standard. It's been around for about 10 years, since 2015, and it's for protective curtains. However, it is tested both vertically and horizontally, and everything else that we've looked at is tested either vertically or horizontally, with the exception of floor slab construction under ASTM E119 or UL 263. Why is this important? How does that help us? And is the same as UL or NFPA 288? It is not. But how is that helpful? So let's look at, if we put an ASTM E119 system across that floor, it is a continuation of the floor. You legitimately have two-story volumes. And now in the new code, remember, 2-story volumes are only atriums if they're in hospitals or if they're in jails. So if this is a business occupancy, you no longer have atriums. And the only thing that triggers smoke control system is an atrium. So these could be 2-story volumes, 2-story openings as defined in the code within a B occupancy. Now, if this is a hospital, you still have two-story atriums, and you still have to have smoke control. So it depends on what your occupancy type is, what you can do. But an ASTM E119 system substantively and completely separates those two vertical openings from the one original vertical opening. What else can we do? NFPA 288. This is for floor and roof hatches, as we discussed a moment ago. It's load bearing. You can walk all over this thing. You're not going to see it in this application, but nonetheless, technically you could do this. It's load bearing and it has heat resistance. So in addition to a normal opening protective, heat cannot emanate through this, at least above a certain threshold established by the code. But that goes hand in hand with load bearing. So if it's load bearing, you don't want heat going through there either, because if I'm the load that is bearing on that hatch, I don't want to combust. So those two things go hand in hand, combustibility and load bearing. If you have no requirement for load bearing or no capacity for load bearing, you have no requirement for combustibility limitations either. But this is a viable concept, if not an applicable practical solution. It is conceptually viable. So what about UL10D? What are we doing here? What's this all about? UL10D, remember, it's not a load bearing or heat resistance system. It is fire rated. It will stop the fire from transmitting between the two, but it will not stop heat from emanating through the system. So how does this get us anywhere? Remember, we can use an NFPA 288 system, and the advantage that it has, the fire endurance test is identical in UL10D and NFPA 288. There is no hose stream test. There is no hose stream test ever applied vertically onto a horizontal surface. It just doesn't exist. And you can read any of these tests and read all through it, and they will never mention that. Also, the test itself for hose stream, same thing. It is always horizontally applied onto a vertical wall without exception. So what's the advantage? Well, UL10D doesn't have load bearing capacity. We also have a guardrail running around there that we have not taken away yet, and we don't plan to. So you can't get out there. And the temperature penetration through here is unlimited. So you can have a 1800 degree fire down below, and that can be pushing heat up through above, and it can do that. But you can't stand on that curtain, so you're never out there. This is, with respect to your inability to get out there, the functional equivalent of NFPA 288. Again, if this is your smoke control system or your solution for an atrium, you need a fire protection engineer, but fire protection engineers are going to substantiate this all day long. Okay, so let's look at an application of this horizontal concept. This is a building in downtown Cincinnati, Ohio. It's an 8-story building and has a 5-story atrium within it. What did the architect do in this case? Well, this is the top of the atrium looking down, and then it's the bottom of the atrium looking up. But he has protection on this. So what did they exactly do? If you look at this image, you can see the housing for a horizontal system down below the concrete slab, closing off the opening, not that we're standing at, but the one just above us. How does this work? There's a reasonably close proximity to a building section on this project. If we have this 5-story atrium on the top 5 floors, what do we do to close that thing off? Well, the architect chose to do this. They provided horizontal systems. And actually, the systems, I believe that lower one should be 1 floor above that, but separated out so that the end result is that no greater than 2 stories can atmospherically communicate. This was done under the IBC prior to the other option being added. So that was the option for omission of smoke control. But this embraces smoke control. This is a smoke control system. It's just a passive smoke control system. So those are your different volumes that are separated out. Again, no space is going to atmospherically communicate with any greater than 2 stories. Now remember the definition in the code, this is under the 2018 or prior, and that this is a business occupancy. What you're left with is a 5-story atrium, but what you're also left with is an inability for any more than 2 stories to atmospherically communicate. That's the equivalent of multiple atriums, none of which are greater than 2 stories. This is still a 5-story atrium. But again, with regard to smoke, smoke doesn't know that, and smoke can't travel from any more than those groupings of 2. We're going to talk about some cousins of atriums, just because you may be in a position where you can apply one of these. So it's important to cover these as well. 2-story openings is one that we frequently see. Remember, since the definition changed, if you have a business occupancy with what was once a 2-story atrium, it is no longer a 2-story atrium. Well, what could it be? You might choose to call it a 2-story opening. And you can do that. That will satisfy the requirement of a 2-story vertical opening in a business occupancy. But if it's an I2, what's going to happen now if we try to make it a 2-story opening? Well, you can't call a 2-story vertical opening a, quote, 2-story opening if it's an I2 occupancy or a hospital. But then again, on the atrium definition, a 2-story vertical opening, it can be an atrium if it's in an I2 or an I3. So these 2 sections of the code are in harmony with one another. But you can't connect more than 2 stories, or of course it wouldn't be a 2-story atrium. You can't connect to a quarter in a group I or R occupancy. That's not to say you can't do a 2-story opening in an I or R occupancy. You just can't connect to a quarter. And it's separated from any floor openings or any air transfer openings separated by fire barriers. So let's take a look at this. If you have this space right here in a B occupancy, you can call this a 2-story opening. You cannot call this an atrium in a business occupancy. Now, if we jump over to a hospital occupancy, You now can't call it a two-story opening, but you now may call it an atrium. As a matter of fact, you have to call it an atrium because that's the only qualifying vertical opening in a hospital. What if you had another one next to it? Well, if you had fire barrier separation between the two, you could legitimately say these are two independent spaces. And you can legitimately say that there's a two-story opening over there, and there's a two-story opening over here, and they don't connect, and you have two legitimate, separate two-story openings. So here's a question for you. In an R occupancy, and you have a two-story vertical opening, and it qualifies as a, quote, two-story opening, can you put a corridor right there? Remember, we discussed this a moment ago. It cannot be open to corridors in a group I or a group R occupancy. That's not to say you can't use it in a group I or R occupancy. So what if this was an assisted living? Let's drop the assisted. Let's say this is a senior living or an apartment complex. We can have a two-story opening in either one of those occupancy types, but it can't be open to a corridor. Okay, so what do? What does separation from that corridor mean? Code doesn't say. However, if you go over to the section on corridors, it very clearly tells you what you have to do to separate the corridors, and that's using a fire partition to separate it out. Now let's go back to the two-story opening. Are we separated from the corridors? Sure we are, with fire and smoke rate separation as well. Let's talk about exit access stairways and ramps. Now you can have an exit access stairway, and it can remain unenclosed. So if that connects two floors, can you do that? Well, again, we have the limitation on I2 and I3s, which is in harmony with the requirement for atriums, because that hypothetical two-story connection that is unenclosed would then become an atrium in I2 or I3. But can you have an unenclosed exit access stairway in a business occupancy, for example? Well, it can be within a two-story opening that is separately defined as a two-story opening. That's one possibility. It could be within an atrium. And so then it's not limited to 2 stories. It could be 3 stories or 4 stories. You've protected that as an atrium anyway. All you're doing is putting a stair in it. So you could do that. Or there's another option too. This was a little hard to read, kind of will tie your brain in a pretzel knot if you haven't had your coffee today. But if the area of the opening is no greater than twice the stairway footprint, you can have an unenclosed exit access stairway protected only by draft curtains. So you have to sprinkler those draft curtains, protect the draft curtains, which are in turn protecting from smoke movement beyond a certain degree. And then there's a limitation as to how high this could be. So you can have in a business occupancy, let's say you want to connect 3 stories of a business occupancy. You can penetrate the floor and you can make that a big opening. Then it becomes an atrium. But if it's a very small opening, it's there only for the purpose of an exit access stairway, which is permitted to remain unenclosed. If that opening size is no greater than twice the size of the stair, you can do that only with draft curtains and closely spaced sprinklers. So let's look at that. Let's shrink the opening down a little bit. There we go. That's probably about right. And now let's put the draft curtains down there. What is a draft curtain? We see them all the time. They're always made out of plexiglass. Is there a requirement for that? Nope. But you see them a lot in building types that want to promote visibility. You see it in retail. It's all about visibility. You see it in other occupancy types as well. Airports, where you have signage. You're wandering around an airport. You don't know where you are. Where's baggage claim? I don't know. Where's the ticketing counter? The signs are there, but you don't want to block it with something else, so they make them out of plexiglass. With that said, there's no requirement for plexiglass. It's just a functional convenience, let's say.
This concludes our AIA Continuing Education On-Demand presentation. On behalf of SmokeGuard and the EBS Group, thank you for your time and attention. As a reminder, you'll need to complete a 10-question test to receive credit for this course. Simply click the test button below to get started. After completing and passing the test, you will receive your AIA Certificate of Completion by email to the address you provided before taking the test. If you're an AIA member and you provided your member number, we'll submit your credit directly to AIA on your behalf. Please allow up to 10 business days for your credit to appear on your AIA transcript. To recap, SmokeGuard's core offerings include standard and custom elevator smoke containment solutions and vertical, horizontal, and perimeter fire and smoke curtains. If you would like information on any of our products, design support, or additional AIA presentations, you can contact our support team or visit our website. Additionally, the EBS group offers AIA-approved courses on life safety products. Balco covers expansion joints, photoluminescent egress systems, and fire stopping. SmokeGuard focuses on fire and smoke protection solutions, and Greco offers courses on commercial architectural railings and code compliance. Scan the QR codes or visit their websites to explore all available courses. If you have any questions or would like more information on SmokeGuard, visit our website at www.smokeguard.com. Thank you again for your time and interest. We look forward to seeing you on our next AIA On Demand video presentation.